This is a production of Cornell University.
I just wanted to say it's a pleasure to have this opportunity to introduce Dr. Rajagura Bohar. I've known him since 2009, but I'm going to give you a little bit of his background. He has an interesting CV. He earned his bachelor's, his undergraduate from Tamil Nadu Agricultural University in the southern part of India in 2009. He had focused his work on agricultural biotechnology, and he was studying the DREB genes in rice. For those of you who know, those are genes associated with drought response and abiotic stress tolerance in rice. And then he continued his work at Tamil Nadu at TNAU, and he earned a master's degree that was done in conjunction with the Tata Cornell program. He also focused on biotechnology, but he combined that with business management for his master's. And that degree was from 2009 to 2011, but for the 2009 to 2010 year, he came to Cornell as an MPS student in plant breeding and did his research in my lab. So that's how I got to know Rajaguru, and I've seen him many times since then, including this one time here. I'm showing you a picture of us at his home university in Tamil Nadu in 2015. Anyway, he went on. He's had various different types of employment. He worked in industry. He worked for Rossi Seeds in India as a scientist in molecular breeding. He joined ICRISAT in 2018. I believe he worked there for 3 years when ICRISAT was at that time still part of the CG. And he was a project coordinator for the high throughput genotyping project. And there he was working across many crops. In fact, I ran into him several times at ICRISAT during that time because he was also part of the Gobi project. He then transitioned to CIMMYT when ICRISAT left the CG, and he's still at ICRISAT on campus, but he works now through the CIMMYT coordinated headquarters. He's the regional genotyping coordinator for South Asia, so he's still in India, but working for CIMMYT. He's a senior manager in the CGIAR Excellence in Breeding program, and he helps to optimize the flow of samples from breeding programs to genotyping centers and back to breeding programs to facilitate the routine implementation of genomic selection and efficiency in breeding. So you'll hear a lot more about that work. And I just want to ask you to join me in welcoming Dr. Bohar to give his seminar entitled Empowering CGIAR-NARES Breeding Networks, Connecting the 3 Dots of Discovery, Validation, and Unparalleled Services through CGIAR-BRS Lab Services for Global Access and Impact. Rajaguru, the stage is yours.
Okay. First, thanks, Star, for giving me the opportunity to present to my home university students my experience with these CGIAR and then several functions within breeding network. I feel very excited to be introduced by Susan, who was I would say, the main pillar who brought me here, introducing me to the field of plant breeding, and then guiding not only with my graduate program, even after that when I joined the industry, and still now in various capacity, I was getting guidance and support. Thank you so much, Susan, for all your support. So without further delay, I would like to get into the seminar for want of time. So good afternoon, everyone. I'm very pleased to be present here and share some of my experience within CGIAR and NARES breeding network. So don't be scared with the big title. I'm not going to steal a lot of time. I'm just going to give you a glimpse of what we are really doing with connecting, this discovery, validation, and services for CGIAR-NARES network. Okay, so I just wanted to share some of these pictures which I had. When I was compiling these pictures, I was taken back, it was 15 years ago. So it was in 2009, I had a good experience when I was in Cornell. Thanks to the entire, my teachers when I was there, especially Susan, Mark Sorrell, and several other faculties who, introduced me to the field of plant breeding and how fascinating it would be when we take a plant breeding field as our career. So this first one is, you could see Mark standing over there. And then several of my classmates, they were, either they were in the seed industry, academia, or CG as well. And then the next one, I pulled out this picture when we went to the Apple germ blossom collection field. And then this one is with the bear. And then the last one with the Susan's lab. So just to share, the wonderful time I had with Cornell University. So this is also, because we are going to start my slides with some challenges. I always wanted to start something positive. So I just put this slide as a staff holder. Okay. So before introducing to the current work, what I'm doing, I just wanted to introduce the connection why we are here. So as you all know, this graph would be very familiar to you, seen in many publications and then talks. So, the increase in populations. So with every year increase, we have more mouth to feed. As of, 20 or so, it would be, like almost 10 million mouths to feed. So this is one side. And then in terms of undernourishment, still, you could see a drastic reduction in the percentage of undernourishment, but it's still in the higher side. And then if you see the predictions is that it will go back to, where we started in 2005. So there are a number of ways to address these challenges, how, you're going to tackle the menace of climate change, the population improvement, the poverty, the undernourishment. But then plant breeding holds an important role to address all these concerns. There are a lot of technologies and then improvement and then modern tools which enhance this process of tackling these kind of challenges, especially this population improvement and then climate change and then undernourishment. I'm more going to focus on the molecular breeding, especially molecular markers, which is my area of expertise, and then where the excellence in breeding I was operating with. So there are a number of, molecular tools, including, when we started with PCR-based marker to the next generation sequencing, they address a similar kind of challenges, which is, increasing the efficiency of crop improvement or product development, or decreasing the time interval taken for the product development. There are pros and cons when you see in terms of comparison of different molecular markers. So you would really appreciate why I'm bringing all these, bits and pieces together when we finish this seminar. And then when you talk about, the role of molecular markers, I wanted to give a little bit of glance on this genetic gain reduce equation, where how these molecular markers are playing a critical role in increasing genetic gains, either in terms of, increasing the selection intensity, where the utility of molecular markers improve this selection intensity to a high level. And then, at some point, including the technology like speed breeding to reduce the length of the cycle interval, thereby increasing the genetic gains. Even for that matter, you need molecular tools for selection or to complement the speed breeding technology, thereby you can increase the genetic gains. So with this all note, I'm just going to jump in right away to the current work, what we are doing, which is connected with each of the every slide. I would come back at the end of my presentation, how we are connected with all these particular topics. Okay, so yes, we understand there is a population issue. There was a climate change. There is a requirement of accelerated genetic gain improvement within the the breeding program, but not just with the CG Center or the public breeding program, we can tackle this issue. So when we wanted to connect to the end, the audience, which is the farmers, the customers, we need the support of NARS program, which is National Agriculture Research Extension Program, across different countries. So realizing this very important aspect, there was a network of CGIAR-NARES. Now, sometimes they now called as CGIAR-NARES SME network, where you do not have this objective of crop improvement just in the perspective of CG, but as a network. So we have a very critical role of NARS and then different public sector and private sector who needs to be collectively work together to achieve this, genetic gains improvement, which is very much required to tackle the issue of climate change, population improvement, and undernourishment. Why I'm suddenly bringing this concept is, so if you see in terms of the access to the technology and then access to the different tools, not all this breeding program has a similar kind of access level. If you see the CG, some CG centers, they may have their own in-house facility to do their either sequencing or genotyping. But if you take a small breeding program or small even NARS network, which is the end stage where your product get delivered to the audience, they will not equally get the opportunity to all these tools and technology. So this is the background. So how do you enable all these tools and technology which will accelerate the rate of genetic gains? So I'm going to specifically talk about how we achieved passing this access to the across CG-NARS breeding network in terms of genotyping and other services, which we operate in the model of shared services, so that they do not require this facility to operate such access. So I'm going to introduce to such models. So before getting into that, I would like to take a minute to introduce to CGR Excellence in Breeding Program, where currently I was currently working with. So the main objective of CGR Excellence in Breeding Program is to modernize the breeding program for higher rate of genetic gains and variety turnover. So they mainly focus on product design and management, optimizing breeding, tools and technologies for genotyping and sequencing, phenotyping and bioinformatics, and they have a NARS module. Collectively, the goal is to modernize the breeding program, not only with the CG Center and also for the national network. So most of you would have already know about the development of one CGR initiative, where all the CG centers are coming together under the single umbrella. So with that, EAB is transitioning into a new brand called Breeding Resources. So Breeding Resources is one among the different initiatives of one CGIAR, where each of these modules has been transitioned into different initiatives. For example, the genotyping, phenotyping, and bioinformatics and data analysis, those kind of support services comes into the breeding resource module. So currently, genotyping and sequencing within EAB is transitioned into the breeding resources, where we operate not just as a policy advisor, but in the institutional framework. So this particular slide, which will help you to understand where we are in the whole process of breeding process model. If you take, there are several stakeholders and several functions which is working together to achieve the entire breeding process model. Let it be the gene bank or the product design, trait discovery. So these were different functions. And then there are a set of functions like breeding analytics, training and nursery, lab service processes, which were recurring breeding operation processes, which is cut across different functions. So we are, let me just take the pointer. Okay, so we are here when we say the genotyping module, where I currently belong, is placed in lab service processes, which takes care of all the genotyping requirement. If there is a requirement of genotyping in trait discovery and deployment, we work with them. If there is a requirement of genotyping in germplasm characterization gene bank, we work with them. If there is a genotyping requirement for adoption study or DNA fingerprinting for varietal identification, when it goes for scaling or seed system, we work with them. So irrelevant of the function, wherever there is a requirement of genotyping and then genomics tools involvement, so we work with them and then we will implement the required tools and technologies. So I would like to introduce some of the genotypic services which are offered through the Excellence in Breeding and currently with breeding research services. So this was I would call it as a product. So we operate in more in terms of business aspect. So not just with service, we connect with the different stakeholders, including the breeders, the molecular scientists, the National Breeding Program, the CG Breeding Program, through a shared service principle, where we have an engagement with an external service provider. Currently, this service is offered through Intertech. So the way how we operate is, so we have this all these molecular markers coming from different crop, different institute. We put together in a single platform and then made accessible through the external service provider, where any of the partner institute, let it be the national program, the universities, the approved private seed sector or small and medium enterprises, or the CG breeding program in different regions, they can just send their leaf materials and get it genotype for whatever the crops which we are engaging with. So this is a publicly accessible documents. You can go to this web link and then click any of this icon of this crop, which will give you the the Excel sheet, which contain what are the genes and the traits, the markers are available. You can just code the SNP IDs and send your leaf material and get the data back at a very competitive pricing. So this is how we operate. We negotiate with different vendors and scout for the right service provider. And then we make these molecular tools accessible through the service provider for any of this breeding network, which I mentioned. So this is how we operate. So this started with this high throughput genotyping project, where I was working initially with the CG, and then that later transitioned into EIB, and now we rebranded that as a low density genotyping. So where this is a CASP-based chemistry, specifically focusing on trait-based marker work, like marker-assisted selection. And then later we realized there is a requirement of quality control parameter in the breeding program. Your F1 purity testing, seed purity. Then we more concentrated on bringing up more quality control markers for most of these crops. These QC markers are currently available. So for this low density CASP-based assay, you can utilize for trait-based genotyping and also for QC. And then later we, this was maybe like from 2016 to 2018-19 or so. We slowly brought more crops into the picture, and then more partners and service user. And then I could recollect, we coordinate almost like $2 million worth of genotyping between 2016 to 2020 through the HTPG project. And then later we understand there was a push for genomic selection so that the products reaches the market in a very shorter period of time, and also it has a great role in accelerating the genetic gain. But the low density Casper-based markers were not so sufficient to address that particular GS. Then we started working with the CG molecular team, and then scouted for different technology which could address to give the genotyping in terms of 1,000 to 5,000 marker density, which is required for the genomic selection at a very cheaper cost. We have multiple options even currently. either the chip genotyping, different sequencing technology, which can give you more marker density. But then if you talk about implementing that particular methodology in the routine breeding program, the very essential factor is the cost involved and the turnaround time. So we keep these two factors very particular, and then offering this mid-density genotyping in the range of $12 to $13 per sample, independent of whatever the market density. So these are the current marker panels which is available through the platform. Wherever you have this hyperlink, those were already implemented. You can just click and then see the background, how those markers were developed. For example, I would take the example of sorghum. Almost like 800 to 1,000 lines, sequenced data, the chip data, whatever the sequence information and SNP information, those were collated, and then they came up with 3,500 markers or so, which were put into the DARTag platform. So this is a DARTag custom amplicon sequencing technology. Should not become confused with the .seq, which may be, you get kind of a random or a different type of results. This is a custom amplicon sequencing technology where you get, the accurate data at a very cheaper cost. And then how we operated here is, instead of focusing just the CG program or NARES breeding program, we targeted the crop network across different regions. For example, for sorghum, when we started, we invited different audience, like, we invited Kansas State, we invited ILSI network, we invited different national program working with sorghum, MBRAPA, CG community. And then these markers were showcased to them. Whatever traits or markers which is missing from this panel, different partner, they have offered those markers information. And then it is being like a global panel, which is being utilized by different audience for different purpose. So this is how we operate. And then we are also constantly upgrading. For example, if you see, 2.0, which is we started with a minimum set of marker initially, and then it has a flexibility to upgrade this panel. So I think for wheat and maize, we have 2.0, which is a second version. Potato, we are currently working for the second version. And then for rice, we have this 1K RECA panel through this platform. There is an ongoing process for improving the panel for increased density, 4K. We are also working for bringing up a 4 to 5K haplo panel, targeting different haplotypes for rice functional genes. And also trying to apply the same model for bringing a pathogen panel for detecting the different pathogens, rice pathogens, by bringing target SNPs for that particular, pathotypes. We are also trying to see if there is a possibility to bring a multi pathogen panel where different SNPs for different pathogen of different crops can be combined in a single panel, so that the pathology function can also utilize the similar methodology. So this is a nutshell about the mid-density panel. This is also publicly accessible document. You can go through this link and then see the background of how it was developed and what purpose this panel can be utilized. So this is about low density and mid density. And then during this process, we realized, for many crops, there was no proper reference genome assemblies available. For instance, they may come from a wild variety, which is not so relevant with the allied breeding material. So when they go for marker calling, so they face many challenges. So through CTH project, Crop to Hunger project, so we got a possibility to have a new reference assembly for different crops. So we scouted for the available reference genome, and then we ran through a process and figured out what are the key crops which requires new reference genome. And then we started working with banana, yam, and then cowpea, and so many other crops. And then most of the crops, those were under pipeline. Some of the new reference were already released through the CG data portal. You can access these data for the released banana and then plantain new reference genome through this data portal. Along with that, we are also constantly working with different service provider to provide whole genome resequencing at a very affordable cost. If you see different CG breeding program, for want of characterization or marker discovery, still there is a requirement of routine resequencing in their work. We see there is a opportunity to bring that cost down. So we are working with the two service provider to have a negotiated pricing for most of these crops. So for rice, we have piloted through Textion, and the results are coming good. And then we are also using that particular SNP data for development of new 4K panel. So as of now, you could see a lot of services for genotyping. And then bringing the success story and then experience with this, providing genotyping services, we realized the same kind of model can be also applied for other services. So we did the demand assessment. What are the services, which is currently required by the breeding program of CG and the NARES partners, where they face either challenges or the cost is very high because we don't have a collective bargaining power. So in the genotyping services, the one particular thing which we have tapped is the collective bargaining. We collate all the sample demand from different CG center national program across the globe, and then we negotiate with the service provider with a collective bargaining power, where we were able to bring down the cost and then a substantial reduction in the turnaround time, because we formalize and then standardize a lot of these logistics, which is so much essential for the movement of sample from different regions to the service provider. Taking that experience, we are piloting for the nutritional testing. Currently, we are trying to have a similar kind of model for elemental analysis of iron, zinc, and aluminum. So we are having already an agreement with Intertech for providing this analysis through ICP-OES. And also we are partnering with Harvest Plus, where the internal labs through Harvest Plus located a different region, the XRF, and then facility can be utilized for non-destructive analysis of iron and zinc. Why we started with iron and zinc is, as you all know, we are into the process of biofortification, where iron and zinc were pioneered in terms of mainstreaming these nutrients into the products. So either in the discovery process or in the breeding program or in the product level, there is a routine need of testing the iron and zinc. So we brought down the cost to a substantial level, and then the breeding program started submitting the samples for initial test validations. If you see, there are so many number of partners and so many number of stakeholders involved in this process. Currently, everything happens through email communication. We have an order forms that must be filled and then communicated to the AAB coordinators. We check them and then communicate to the vendors. It's a long process, and then there is no accountability or traceability of all these orders. Imagine 18 plus crops and then different services, different NARES partner, different countries. So these samples will go to any of the 3 labs located in Sweden, Australia, and India for the low density, and then further to DART in Australia for mid density. And then if you see sequencing either to the US or Australia, so there are multiple regulation of sample movement involved. So we thought that's a requirement of developing a portal where we can manage all these services. So we launched this platform called Genotyping Submission Portal. You can register through this link if you want to submit your samples for low or mid density, or for nutritional testing. Also, we are trying to bring the similar kind of model. There is a pre-launch demo you can see in YouTube to watch how to access this portal. Why I brought this specifically to the seminar is if some of the students working with different crops find some of these markers available through the platform relevant with your current project or in future with your breeding process. So you can access all these services through this one particular platform, where we will manage the backend for your access to these different services. Okay, so these are all the tools and services we offer. We also, constantly give training and backstopping. We engage with different new partners in Africa and Southeast Asia. We work with them, go to their field, and then train them in terms of sampling and logistics, and connect them with the different analytics group for the data analysis and so many other related analysis network. So we help them in terms of, right from going to the field, collecting the sample, processing the sample. So we'll be always, hand holding them until their first data comes back. And then even after they get experience, we always go, backstop with further follow-ups, and then helping them in terms of implementing the genomics into their routine breeding program. And then if you see, I'm not just talking about theoretically how this is possible. I'm talking about, a model which is implemented and then tested in different crop, different region, and different functions. These were some of the, example of some of the success stories. If you see, a lot of publications came up. We don't, involved with, our names being included in the publication. I'm just showcasing this, how these services are, applied in either discovery or implementation. Or you could see a lot of, validation done for different traits and then implemented through the platform. You could also see a lot of publications and success stories, case studies, where these particular shared services being used to implement a lot of QTLs or genes into the breeding program. So the way I see this is, there is no limitations for the breeding program, irrelevant of where they are coming from, how big or small their breeding program, or how big or small their institute. So they have the possibility to access all these tools and technologies through this platform. So this is the way I see how this is, being successful in different, crops and different networks. I just wanted to spend a couple of minutes, explaining this one. So I just pulled out different partner networks who are involved in this rice breeding network, and then potato network, and wheat network. If you see the rice network, if you see, most of the markers are coming from ERI. But then if you see our user database, these are some of the Indian national partners who are constantly utilizing this ERI marker through the platform. And then we also, opened up to the small breeding network in the private sector through the public-private partnership. They can also utilize these markers, but at a different pricing structure, which is now only applicable to the non-profit. They have a different pricing structure, but they have the access to this particular marker. And then the same markers are utilized in Bangladesh NARS berry, and then Philippines NARS field rice. And then if you see, the national partners also offering their tested markers through this platform, where recently we got a DSR related marker from PAU validated in their institute. They offer through the platform, which is accessible by the rest of the audience. Even within CG, the markers from ERI can be utilized by the Africa Rice Program or CIAR program. And the marker from CIAR Rice Program can be replaced by the rest of the NARS and the ERI network. the same thing, talking about potato or wheat, the markers coming from CG center, how it get penetrated and being widely utilized by different national programs. So this is how I see, the success of shared genotyping, where the production ready validated markers are not just restricted with the one particular lab, and coming to this platform, being widely adopted and then implemented into their routine breeding operation. So we are very small team. We have Eng, who started with this HTPG and then the module lead of EAB and also BRS. We have other colleagues based in Nairobi, taking care of ESA, and then in Africa is taking care of WCA, and I'm sitting at Hyderabad, taking care of South Asia, and now more involved with Southeast Asia as well. So you can contact any of us, and we have a general contact. If you drop us an email on any of these request for either genotyping or nutritional testing, we'll be happily addressing your concerns. And I would like to thank all the donors, contributors, vendors, and service users. This one particular picture we took during the annual meeting together with San Diego as a sideline meeting with PAC. You could see many of, I think Mark is here, and then some other Cornell faculty and students might be there and here, and then Star is present. So after this, we got into the menace of COVID, so we couldn't convene such a big meeting. And then this is our core team guiding these breeding research services. This is a team with GSL, IRILA. I was closely associated and then aligning their breeding process model and then the BRS model, harmonizing the process. So this is a very small contribution pictures, but there are still many of other contributors who helped us to build this network, offer their markers, services, and then constantly upgrading these panels to be enabled to not only to the CG program, but also to the rest of the national partners and other public breeding programs. I also wanted to take this opportunity to thank the donors and also a different partner institute who are constantly engaging with us and adopting the genotyping services for a very long time. So this is the end of the slide. With this, I thank you very much for patiently listening, and be happy to answer if you have any questions. Thank you so much.
Yeah. So for the people in the room, and also we have now 18 on the line, feel free to share comments or questions for Rajaguru.
Okay.
Go ahead. Yeah.
I'm curious, what are some of the biggest challenges you face coordinating the processing of such a huge volume of samples from so many geographic locations, and also the processing of the data and the movement of the data, and what are kind of solutions that you found for these challenges?
Can you hear the question okay, Rajaguru?
Yeah, if I understand correctly, you are asking about the biggest challenge faced in coordinating with such a wide audience and the different regions. Is that correct, Star?
That's right, yeah, and also
Okay.
the volume of samples that you deal with from so many different locations. What are some of the challenges that you faced and how you're able to deal with that?
Yeah, so yeah, that's a good question. This the biggest challenge we face. To have a good quality data, you should have a good quality samples. So if you see, some of the samples are coming from the remote regions, the time taken to get those samples delivered to, different labs, that's one big challenge. And then the other one is the rules and regulations. Different countries have different rules and regulations in terms of leaf sample movement or DNA sample movement. So we need to, sort out all those issues. So these were some of the logistic challenge. And then the other thing is different service user will be at a different capacity to implement this particular molecular aspect into the breeding program. So we need to assess where they belong. So it's not like we can directly implement genomic selection for starters. So we sit with them, we understand their breeding principles, and then the status of their breeding program, and then slowly we start with either genetic characterization. So assessing a different audience, that's being the other challenge. So with the years passing by, we are learning from past experience, and then transforming the way we handle all these issues. So we sort of overcome all those issues in the past few years. Thanks.
On the line, we have a question from Bethany. Many national programs meet the minimum sample number for the intertech data contact. Have you developed mechanisms to help small programs utilize these services without having to pay an increased price per sample due to their smaller sample size?
Thanks, Bethany. So I think this being a question floating around from, we are getting constantly these questions from different audience, but we are constantly engaging with the vendors. I just wanted to pinpoint one particular issue, technical limitations with the lab, where they operate all these genotyping through the liquid handling device, either with the 384 or 1536 modules. So that's the reason they were not able to just stick with 1 or 2 96 plate, because even with that they need to spend all the consumables which were required for 384. Being said that, we receive a similar kind of request from different audience. We are working out some ways to handle that. For example, we negotiated with the vendor. For instance, Bethany, you might be already knowing, after 384, if you submit one more extra plate, earlier it would be counted as the next batch of 384, and you will be priced for 8 plates. Now we are negotiating after 384, the 5th plate may have just 30% more cost or so for a one single plate, and not calculated on the basis of all 4 384 set. So this one aspect we are discussing for the possible implementation, but we are also discussing with them how we can engage a different user who have only 94 or 192 samples or so. The other way how we are tackling is combining samples from different programs which have a similar genotyping needs, and then assembling a 384. We could recollect, we did this for some of the rice and then cassava program, and then combine the samples from different audience. So yeah, I think I can explain it later as well in some of our future meetings. Yeah, thank you.
Yeah, so Leah, before I call you, we have 2 more questions, okay? Yeah, so you raise your hand. Go for it. Go ahead.
Oh no, I'm clear now.
Okay.
I wanted to be clear if they were taking, if they're performing like samples for people. I'm clear on.
Oh, you're clear now. Okay. Someone else? I saw raise hand. No? Okay. Oh yeah, please.
If they are estimating the nutritional content of any kind of seed through non-destructive methods, is it effective in small sample size?
Okay.
Star, can you repeat? I couldn't hear it properly.
Yeah, for nutritional analysis for the sample, non-destructive method is that there's a problem if the sample size is small. Is that right?
Yes, the sample size is small. Is there any problem encountered if the sample size is small?
Sample size means
non-destructive methods of estimating the nutrition quality.
could you give an example, like say rice, like how many lines small? Or
So maybe you can provide the microphone.
Okay, yes.
There.
So if you are using non-destructive methods of estimating the nutritional quality, or for that matter, any seed quality parameter, if the sample size is small, will that be effective enough? or will it be a representative of the whole seed lot?
So we are just starting that with nutritional testing. We just launched it. We still figuring out the validation process. So we have our knowledge partner Harvest Plus who is helping us with this nutritional testing. I apologize, I was not very much expert in that field. So maybe I could link you with that Harvest Plus group. So they will be helping you, in terms of if you have any technical questions. Feel free to reach out to me. I'll be happy to connect you with that data. Thanks.
Yeah, I think this is a statistical sampling question. Maybe ask Kelly. By chance, I also did my postdoc on seed green quality analysis for soybean. Definitely, this will be a concern, especially in your packet, in your bag. The seeds are heterogeneous, right? So you need to see the fixed line and also how well the sample is grounded. If it's non-constructed, your sample versus your population. Okay. Yeah. So online, Leah, unmute yourself. Feel free.
Oh, thank you for the great talk. So from the talk, I understood that you have done great work in training the national agriculture systems, the NAS systems, on how to collect the samples and send to you the samples. Do you have any program on training champs or people, on how to use the data, or you just give the data to the national program and then whatever they do with the data, it's their issue?
Yeah, thanks, Leah. That's a great question. Earlier, we used to have different modules. We conduct, 5 days program where we, go from the AB team, from the genotyping space. We help them in terms of sampling and then the logistics and then sending samples, all those things. And then we also invite, data analytics team who would help them, training in terms of, for example, giving a demo on Flapjack or some of the basic Galaxy tools to analyze the data. So, and then later, we have a specialized team who are working in the space of data analytics. So some national partners, they have their own data analytics team who would, work with their data. If some national partners, if they are having troubles in accessing or analyzing data, we will loop them with the rest of the EAB module who is taking care of data analytics. Right now, we are also working with the data analytics team to see how we can give genotyping and data analysis as a package where any partners can request genotyping and data analysis. We see there is a lot of scope. We are working on that. Currently, we are dealing that by case basis, and not as in a generic way. But that was a really interesting aspect we are dealing with.
Thank you. Just a follow-up question. Do you charge for the data analytics or it's a free service?
As I said, we don't have a structured way to help with the data analytics. Currently, we stop with delivering the data and then later connecting them with the right research group who can help them, either providing training on data analytics or just helping with that particular data set. So we are doing that case by case, but not in a chargeable mode. We are just referring to the different experts. Further, they are following with the national partners. And there are also specialized group working on data analytics, and they were also working on developing modules where you can do the data analytics without through programming or coding. By graphical interface, by simple tools, you can get your analytics done. So that's a work in progress. It will take some time to implement that, but it's completely different from the scope of our.
Okay, thank you so much, Leah, for asking the last question. I think your last question actually also alluded to our next speaker. That's Dorcas. She will represent the breeding analytics. As Rajagura showed you, there's other service in data analytics, and there's a capacity building, partner building, I think with university like Cornell, there could be a lot of partnership in connecting the genotyping, the nutritional quality, and then also the downstream data analysis and the complete loop. And we'll save that for next Tuesday. And for today, let's give one more round of applause to Rajagura. Thank you so much for Rajagura, wonderful sharing and also this very informative speech. Also, thank you, Susan, for the nice introduction. And for everyone joining online and also in the room. Okay, have a good afternoon now. Bye.
Thank you so much for patiently listening. I hope you enjoyed this session. Thanks, Star, and thanks, Susan, for the coordination. Thank you so much. Bye-bye.
Okay. Thank you.
Thank you.
This has been a production of Cornell University, on the web at cornell.edu.